Okay, so we're looking at Terrence Howard's claim about the number one, and I'm trying to argue that what he says actually makes sense. The first thing we need to consider is the difference between number and geometric length that relies on unit. And so if we look at the article, Did the Greeks Discover the Irrationals by Philip Hugley and Charles Saward, they say that no, the Greeks did not discover the irrational square root of 2. And so we'll be getting into why that's the case and what effect that has for science and technology. So basically, the issue is, how did the unit get defined? And what happened with Platonic philosophy is the unit was redefined as what's called the materialistic idealism, or the Platonic ideal, as two-ness. And so what Philip Hugley and Charles Saward are demonstrating is that, well, first of all, when we look at this two-ness, Aristotle did not agree with Plato, because if we quote John J. Cleary's Aristotle's criticism of Plato's theory of form numbers, then we find that the units for the first two can be separate. They're not just two-ness. They can be two different numbers created at the same time. This is what Aristotle argued. So it's impossible that 2 be some nature separated from 2 units. Whereas Aristotle was arguing that there's this inherent symmetry of reality as two-ness that exists before separate numbers of 2, 1 and 2. And so when we apply that concept of the number 1 as a unit, Philip Hugley and Charles Saward, they're philosophy professors, and they're arguing that actually there is no actual proof of the square root of 2. It was never proven, because geometric length requires a unit as a measurement, whereas the square root of 2 is supposed to be just an arithmetical number that's not proven. So most people would say, okay, well, maybe it's not a actual logical proof, but you can see that it exists, the square root of 2 as a number. You can just sort of infer it logically. So they're going through these, that when you ever have a geometric length that you're measuring, then you have to use units, and so you have to use like inches, for example, but that's not a precise, non-approximate number, which would be the case for the square root of 2 as a number. So they did not prove the square root of 2. Now that goes against all rational thinking, in science, because it's the Pythagorean theorem is called the power axiom set in science. It's considered the foundation of all of mathematics and physics, and it's all based on symmetry and commutative geometry. So if they didn't actually prove the Pythagorean theorem, then that that corroborates Terrence Howard's claim that the science has been wrong all along. Now, let's take a look at if that's actually true. How could that possibly be the case? Okay, so when we look at what Einstein did when he discovered or he invented the theory of relativity, I was just reading Professor Alberto Martinez's History of Science book on kinematics as the true understanding of relativity. And Einstein was relying on the Lorentz contractions and on Poincaré saying that if you're going to maintain relativity with the Lorentz contractions, that it goes against Maxwell's symmetric mathematics. The existence of an electrical field was a relative one, depending on the state of the motion of the coordinate system, or you could say units being used. And so one of the big things was this experiment with light in water, the Fitzhugh experiment. I don't know how to pronounce his name, and so Lorentz had contrived what he called local time. And so basically Einstein realized that his big discovery, his insight was that there is no, in terms of the speed of light, simultaneity does not exist. So you cannot have two units at the same time, yet you can still have two units. It's just based on the speed of light. It's always going to be a relativistic simultaneity. And so when most people learn relativity, they don't learn that actually what at its foundation, it's just a debunking of simultaneity. And yet Platonic two-ness is obviously this idea of simultaneity as geometry. And so there's even a book called From Pythagoras to Einstein, because Einstein was basically just extending the Pythagorean theorem for relativity. Now, this eventually gets us to non-commutativity, and I actually have a quote that Professor Basil J. Hiley uses of Einstein, saying that that Einstein realized that Heisenberg was correct, that non-commutativity is the foundation of reality, and that there's no space-time continuum at the foundation of reality. I could find that quote if I really needed to, but so in terms of non-commutativity, then when we look at what the unit 1 actually means, then that leads us to how to define time and frequency as being non-commutative, because it relies on the order of the unit 1. And when you reverse the order of the time, then you get a different space value that's relative. So Alain Kahn, he refers to this as the speed of light. When you have the speed of light invariance for relativity, then time is now defined inherently by the transitional frequency that's non-commutative for the cesium atom. That's currently the invariant definition of time. It's based directly on spectral frequency and not a spatial measurement. So this is a quote from Alon Khan about this. So behind the scene, there's a square root, and when you take the square root, there's an ambiguity. And in that ambiguity, there is a spin structure. And so that brings us back to the square root of 2. It's actually, the truth of the square root of 2 is based on this inherent spin structure that's non-commutative time and frequency. Now this makes sense if you realize that the square root of 2 actually originated from music theory logistics of time and frequency that were inherently non-commutative in Pythagorean philosophy. But this got covered up by Philolaus and Archytas, and then was promoted as Platonic philosophy. Again, with this Platonic ideal of a symmetric two-ness. And so Aristotle, when he critiqued Plato, he didn't really understand. The non-commutativity had been lost already by the Platonic philosophy. So even though he was critiquing the idea of two-ness as the original unit of one, he, as some kind of idealistic geometry that cannot be observed, which later was, called the ether in physics. But he still didn't realize the non-commutative truth of music, that it was changed into the logarithms as commutative geometry actually originate from the wrong music theory. And so when you get into music theory, they'll try to revert back to the square root of 2, but in fact that's a cover-up of the original non-commutative time frequency resonance. That was the truth of orthodox Pythagorean philosophy. So here you have Peter Kingsley saying, by the time of Plato and Aristotle, the doors of understanding were closed. So what he's actually referring to is non-commutativity. So the definition of a paron as the absolute void was changed by Plato to mean a symmetric magnitude. That's, again, was a lie about the music theory non-commutative ratios. So here we see the lie directly in its original form from Philolaus. And there was a professor that finally translated Philolaus, Professor Richard McCurahan. And so he's promoting this commutative view from Philolaus, even though it's not accurate. So he's saying if you take a string, if you have a lyre with strings on it, the result is the same no matter what direction you go. Whether you go from string 4 or string 5 to string 1 or string 7. But that's not true in music theory. They have different values. So that's based on the direction of the one. So if you go in a different direction of the one, then it changes the pitch value. So what Philolaus did was, as Richard McCurahan explains, is he's converting the frequency and wavelength into geometric magnitude as harmonic ratio. So instead of taking 12/9, which is 3/4 of 12, we take 8/6, which is 3/4 of 8. And so by adding the length 12 to 8, we get the length 12 to 6, which corresponds to the ratio of 2 to 1 for the octave. So that's the conversion of the wavelength and frequency into geometric ratios of 3/4, even though the lengths have changed. And when you change the length, it means you also change the one. And as James Brown said, it's all about the one, in music. So you have to, when you listen to the source of the one, which would be called the root tonic, then it changes whether you have an undertone or overtone. So what Philaeus did is he changed the value of the one and then just said, well, it's the same ratio, so it doesn't matter. But that's not how music works. So then he's saying, well, you can just change the order of the one and it doesn't matter. And so based on that concept, then Plato was able to create this idea of two-ness, assuming you already had this octave from a geometric mean squared, which is the Archytas equation. Archytas built on Philaeus, so he had the equation as the arithmetic mean times harmonic mean equals geometric mean squared. So the geometric mean squared is the number 2 as the octave, which then gives the geometric mean as the square root of 2 as two-ness. So if Philaeus says you beginning at the bottom note and descending via another, a fifth above the bottom note. So he says 1 to 4 is the same as 7 to 5. In other words, you can change this order of the ratio, the harmonic ratio, and it doesn't matter. But if you're an actual musician, you know that 1 to 4 is a perfect fourth, which is the pitch C to F. And 7 to 5 is a perfect fourth, but it's the pitch of C to G. And those are different pitches in music. They have a different value. Because when you look at the 1 as an undertone, then the perfect fourth turns into a perfect fifth as C to F undertone. And the perfect fourth as an undertone from 7 to 5 is actually a perfect fifth from C to G as an overtone. So when you're using, when you're trying to say they're the same ratio as a harmonic ratio that can be inverted, you're ignoring the fact that in relation to the 1 as a unit, the direction of time actually changes the pitch value because it's non-commutative. And this is what Alain Kahn calls 2-3 infinity, because the perfect fifth is 2/3, but it's C to G as an overtone, but it's C to F as an undertone. And so Philaeus covered this up, and that's the only way they were able to create the octave scale using 9/8, which was derived from this earlier ratio here of the 8/6 and 12/9. And when you do that, then you can create 9/8 as your major second music interval. And then you can cube the 9/8 to get the square root of 2. And so that's the very first equation for the square root of 2, was based on covering up this inherent asymmetry of time and frequency as non-local non-commutativity. So that's the original lie at the foundation of Western science, and it wasn't until Heisenberg discovered that the transition frequencies of light are, for photons and electrons, are non-commutative, that this ancient truth was then rediscovered. So So Philaeus used 6/8 as 3/4 for 0 to 8 as the 1 unit. And then he reversed the octave so that 12 to 6 is the root tonic of 1 frequency, while 8/12 is 2/3. So in other words, he's using 0 to 12 for the unit 1 for 2/3, and then he's using 0 to 8 as the unit 1 as the root tonic for 3/4. And so by changing the root, the value of the 1, then he's able to create the commutative geometry for the logarithmic ratios that then created the very first logarithmic equation for commutative geometry, and the concept of 0 as a negative infinity. Okay, so now if we get to non-commutativity, again, in terms of the value of the 1, what math professor Lou Kaufman is pointing out is that every time you take a velocity measurement, it takes time to make the measurement. And because of that, every external measurement you make with time has an inherent asymmetry to it. And so we were just talking about the Pythagorean theorem. If you're going to have an irrational square root of 2, you inherently already have this asymmetric time because it's a measurement of length with the unit. And so he explains that this means you can have that the complex numbers and the imaginary number are actually derived from an asymmetric time shift of 1 and -1. And he calls this a primitive time, and this is also what Alon Khan, the Fields Medal math professor, also calls something more primitive than the passing of time. So this is what non-locality means, is that you have a inherent phase shift as a synchrony that is the future and the past overlapping, but before there's any external observed measurement. And so it's also called a primordial time or primitive time. Roger Penrose calls it primordial time. So most scientists, they're not aware of this at all because they just assume based on Einstein. Einstein proved that simultaneity doesn't exist, but then he tried to just convert time into a spatial measurement. But what non-commutativity is saying that the time frequency is inherently a primordial time that shifts as the future and the past overlapping. And so I was reading about the irrational Pythagorean theorem, the original proof for it, and they come up with this difference of 1 and -1 based on the difference between the hypotenuse and the sides, and whether it's irrational or rational, you get this change in the difference of 1 and -1. So you're closing in on the precision towards the square root of 2 as a specific number value, precise value, but you never actually achieve it. And so again, if we realize that 9/8 cubed is actually the square root of 2 approximated, and the 9/8 was derived from 9/4 as 3/2 squared, then we realize that you can't just square the perfect fifth because you have to change the value of the 1 in order to do that. And when you do change the value of the 1, then you're reversing the direction of time. So you have 2/3 as 8/12 but it was actually derived from 0 to 8 for 3/4. So you have it's an undertone as 2/3, but then it's converted into an overtone. And what's fascinating is that in music theory, it's proven that the perfect fourth is never an overtone of the one. It's inherently cannot be an overtone of the one, even though in Western music theory they ignore this fact and just say that you can have 3/4 as a harmonic ratio of the one, but 3/4 is actually the perfect fourth that inherently has to be derived from 2/3 as an undertone. And that again is revealing the inherent non-commutativity of time and frequency. So then math professor Luke Hoffman, he responded back saying, well, did you mean this non-commutative Pythagorean theorem? And he hadn't even published this yet in a paper. But basically he's saying when you have this inherent time shift, because every external measurement of velocity requires a time shift. And so you prove that making that external measurement as velocity then actually can only be behind the actual proof of the Pythagorean theorem. And so you inherently have this imaginary number as an action of time, as Professor Basil J. Hiley calls it, behind the value of 0. And since it's a discrete number, it's never actually squared, because as pure time and frequency, it is before you can have a geometric length as matter. So another way to say this is all matter is actually made of light. And that's what Nobel physicist Gerard de Hooft describes with Martin van der Merk in their essay Light is Heavy. And they're relying on Louis de Broglie's critique of Einstein's relativity. So Louis de Broglie, he basically took it a step farther, and he realized that you had this underlying time and frequency that requires a negative frequency and time reversed correlation or signal, actually. A different, as Basil J. Hiley calls it, it's a new quality of energy. It's a new force, a non-local negentropic anti-gravity force to reality. And so you can access this force through meditation as long as you're not making an external measurement and you're relying on turning light around in meditation. And so this has been covered up ever since Platonic philosophy. And non-commutativity is rediscovering it. And it changes what the meaning of one is, because one is not just a geometric two-ness, but it's as a unit. It's not a square value, but it's actually relies on the order of time. And this is Alon Khan's big emphasis. And so you get this again with the golden ratio, because the golden ratio actually is Freemason philosophy that's relying on the Platonic symmetry of the one as two-ness. And what gets lost about the golden ratio is that, again, from music theory, in order to have a closed proof of the golden ratio, you can have it as a continued fraction where it's 1 plus 1 divided by 1. But as a this is Kepler's critique of the golden ratio. So basically, you have the cube root of 2 approximated by the major third of 5/4, and this goes back to Archytas again. But when you plug that into the golden ratio, you get the ratio of 5/4 to 8/5 for a doubling of the sides for cubing. But the problem is that in order to have a closed form of the golden ratio equation, you have to change the direction of 5/8 to 8/5. And again, you have the same problem where because in music theory they're complementary opposites, so the major third and minor sixth are complementary opposites as ratios. So you have a 5/4 and 8/5 are actually complementary opposites. So you can't just change the value of the major third in terms of time and frequency, because it's an extension of 3/4 as the perfect fourth. And so this is what Archytas originally tried to do, was based on extending those time and frequency ratios with the 5/4 as the cube root of 2. And it's obviously it's great for precision if you want precision mathematics for doubling the cube for catapults, which is what they used it for originally as a military engineer, because Archytas was a military engineer. But it's not accurate, so you have an inaccurate foundation of reality. And so what Roger Penrose points out is that the entropy of matter is the inverse of the gravitational entropy, and the gravitational entropy is the opposite of the gravitational potential, which originates from a quantum negentropy of time and frequency. So when you realize that all matter is actually made of light from time and frequency, then by ignoring the inherent non-commutative time and frequency, you end up increasing the gravitational entropy of matter on Earth. And that's essentially what the ecological crisis is exhibiting right now. So we have what we think it's technological progress by trying to decrease the entropy of matter, but we're actually increasing gravitational entropy on Earth as defined by frequency. So let's see if I have that. Yeah, 5/8. So anyway, I have an equation in here somewhere where I yeah, 8/5 is the minor sixth, and then the major third. Anyway, I'll just leave it at that. So once you realize that there's this secret of the non-commutative time and frequency, then that changes how a number is defined. And this is essentially what Terrence Howard has discovered, even though he doesn't really realize it. And the problem is when people learn music theory, they just assume that it's based on logarithms, and they don't realize that logarithms were created from the wrong music theory. And this is something I've discussed with math professor Luigi Borzacchini. And anyway, Oh, here's the equation I was looking for. So when you double the sides for cubing the volume, you're using the major third and minor sixth music ratios. But when you realize that you're changing that the ratios are actually non-commutative, then you're losing the truth of reality. So you can get this precise engineering, but it's actually goes against the truth of reality of the quantum non-locality. So from Archytas, you had this 9/8 squared. But this cube root of 2 was like an approximation, just as the square root of 2 was an approximation of 9/8 cubed based on the geometric magnitude. And this is something I submitted. I was asked by Joe Mazer, math professor Joe Mazer, to research this further when I contacted him, based on the research of David Fowler. And David Fowler was debating math professor Luigi Borzacchini about this. So I kind of just inserted myself into that debate, and I came up with this article. Here's the actual, this was the debate was on this math forum back in 1999. Anyway, I'll just leave it at that. Thanks for your time.